Good morning, sir.
नमस्कार.
My one करें राशि सर रजनी.
Good morning, everyone. We are starting with the session. Let's start. A very good morning to all the dignitaries, experts, and participants who have joined us for this FDP. I, Rajni Chaudhary, Assistant Professor at Engineering College Banswara, welcome you all on the fourth day of 1 week TechCube third sponsored FDP on recent advances in composite material. Starting with the session, let me introduce you all with the first session expert, Dr. M.L. Meena sir. Sir is currently working as Associate Professor at MNIT Jaipur. Sir has done his PhD in Industrial Engineering from MNIT Jaipur. Sir has more than 13 years of teaching experience. He also developed an ergonomics lab. His research interests include industrial engineering, productivity engineering, material management, operation planning and control, manufacturing technology, work system design, and many more. Sir has published, presented more than 154 research papers in Indian and international journals as well as in conferences. Sir has also been the convener, course coordinator of various seminar, symposium, workshops, conferences, and STC being organized. Along with this, Sir has professional affiliation as Associate Member of Institution of Engineers India, and he is also Senior Member of Indian Institute of Industrial Engineering. Sir has also one patent registered on his name. Not only in the technical field, Sir has wide experience in handling administrative responsibilities too, like Sir has been the TechCube coordinator and nodal officer. It's an honor to have you, sir. Sir, you can start with your presentation.
Okay. Thank you, Jignesh sir and Ranjini ma'am, for introduction. Now I am sharing my presentation. Can you share? Can you see this file? PPT file? Can you see?
No, sir, not.
Okay, it is not visible.
No, sir, not visible.
Oh, sorry, I am urgent now.
Yes, sir, now it is visible.
Okay. Good morning, all of you, participant and other colleagues. So today topic is a case study of polymer composite material. So before in detailing of composite materials, so we discuss about the what is the composite material. Composite material, it is a very very important in point of view in any sector like agriculture sector, manufacturing sector, in as well as in our daily life also. So first of all, in brief about the composite materials. So a composite materials is a material that consists of one or two or more discontinuous components. Components may be particle, fibers, reinforcement that are placed in a continuous medium which is known as matrix. In a fiber composite, the matrix bind together the fiber, transfers load between the fibers and protects them from the environment and external damage. So in uh, further in brief, composite materials are microscopic and as well as macroscopic combination. It may be microscopic or it may be macroscopic combination of two or more distinct engineered materials. So engineered materials means those engineered materials with different physical or and chemical properties with a recognizable interface between them in the finished product. Finished product may be different properties. So before detailing of composite materials, so now we start from basic. What is the engineering materials? So we can see in slide, engineering materials refers to the group of materials that are used in the construction or of man-made structures and goods, components, or any parts. So materials are an important aspect of every engineering design and as well as analysis. There is a wide variety of materials available which have shown the potential in various engineering fields, from aerospace to the in our daily life applications also, maybe in our kitchen, in a house, in bathroom, etc. So household applications also. So it is a very wide applications of different engineering materials. So the materials are usually selected after considering their characteristics, specific applications areas. Based on the different applications, they have advantages and few limitations. So primary function of engineering material is to withstand applied loading without breaking. It is very important. Loading without breaking and without excessive deflection. So we can see in this slide various materials used in our daily life. We can see in this LED. So LED for these light sources for security cameras, blood sensors. We can use in LED TVs, fridge, mobiles, as printer and magnetic recording tapes. So various examples of in our daily life, we use daily life, and it may be in household also. So some of the material used in daily life, we can see in your home or house: wood, silk, cotton, leather, rubber, coal, etc. However, some materials that we use are man-made. Man-made means like synthetic textile, for example, nylon, cement, glass, plastic, dyes, soap, detergents, fertilizers, and pesticides are some man-made material which are commonly used in our day-to-day life. Now this slide shows the classification of engineering materials. So we can see engineering materials includes metals and non-metals. Metals further classified into ferrous or non-ferrous, and non-metals further classified into polymer, ceramics, and polymers further classified. So and so on. So we can now have metal. So metal are the most commonly used class of engineering materials. So metal alloys. Now then alloys. So metal alloys are especially common, and they are formed by combining a metal with one or more other metallic or non-metallic materials. The combination usually occurs through a process of melting, mixing, and cooling. So the goal of alloying is, the primary goal of alloying is to improve the properties of the base material in some desirable way. Now, next is polymers. The polymers are non-metal materials that consist of molecules formed by long chain of repeating units. They may be natural or synthetic. Many useful engineering materials are polymers. For example, plastic. This is the plastic, rubber, fibers, coating. Polymers are also classified mainly two types: thermosetting polymers and thermoplastics. So now next is ceramics. So ceramics also very useful materials. So ceramic are solid compound, includes glasses, cements, clay product, refractories, and other abrasive. So generally ceramic have excellent corrosion and wear resistance, high melting temperature, high stiffness, and low electrical and thermal conductivity. So ceramic are also very brittle materials. So we can go to in slide. So we can see in this metals, this is the classification. So in graphical representation chart, so we can see in this diagram, so composite. So the major classification of engineering materials includes metal, ceramic, polymers, and composites. So we have basic definition in for previous slides, and again in further slides we discuss again in detailing about the composites. So we in this slide, अगर आप इसमें देखें तो प्रेजेंट टाइम में जो कंपोजिट्स है वो कोई भी एक या उससे ज्यादा जो भी आप सेरेमिक मेटल जो भी आपको मिक्स करके इन प्रीवियस पास्ट हिस्ट्री। तो मतलब जो आदि मानव जो थे वो जनरली एक मटेरियल का ही, जैसे एरो हेड बनाया हो, जो भी उनके जो भी ऑर्नामेंट्स थे, तो एक सिंगल मटेरियल का ही एक फाइनल प्रोडक्ट बनाया, जो भी हैमर है या अदर एनी डेली यूज इक्विपमेंट या डेली आइटम्स। बट nowadays composite materials are very important and फ्यूचर अभी भी स्टार्ट हो गया नैनो मटेरियल, बट फ्यूचर जो है टोटली बेस्ड ऑन स्मार्ट मटेरियल, नैनो मटेरियल एंड मेटा मटेरियल। तो व्हाट नाउ आवर डिस्कशन अबाउट द कंपोजिट्स। तो वी कैन सी इन दिस स्लाइड, this is not related to composite materials directly, but basic example of use of composites means the, इसमें केवल आपको इतना बताना था मुझे कि हमारे डेली लाइफ में भी कंपोजिट्स किस तरह से यूज हो रहा है। फॉर एग्जांपल सिंपल एक मिल्क है, मिल्क से हमने उसमें कुछ इंग्रेडिएंट मिक्स किया, मिक्स करते ही उसका बेटर रिजल्ट कुछ हो रहा है। फॉर एग्जांपल योगर्ट बनाना है, बटर बनाना है, मिल्क चॉकलेट चीज। तो कुछ अदर इंग्रेडिएंट्स मिलाने से एक नया प्रोडक्ट आपके पास मिलता है। तो नाउ दिस इज द कंपोजिट in our daily life also. So it is not a directly technically related to composite material, but this is the basic idea about the what is the composites or demand of the composites. Now in this, now start about the composites. So composite, again I repeat, composite materials are engineered materials. So we already discussed what are the engineering materials, what are the classification of engineering materials, types of engineering materials. So composite materials, we can see in this slide, composite material means two, more than one or more than two including. So composite materials are engineered materials made from two or more constituent materials that remains separate and distinct while forming a single component. तो different chemical physical property के हो सकते हैं, और जो आपका फाइनल प्रोडक्ट हो सकता है वो भी सेम हो या और हाई स्ट्रेंथ का. तो फॉर एग्जांपल वी कैन सी इन दिस diagram. So nearly all composite materials consist of two phases. First is matrix and second is reinforcements. So two phases, primary phase and secondary phase. Primary phase means matrix. So matrix forms the matrix within the secondary phase is embedded and second reinforcement, this is known as secondary phase. So embedded phase sometimes referred to as a reinforcing agents because it usually serves to strengthen strong to the composite. The reinforcing phase may be in the form of fibers, particles, or various other geometries. So composites consist of one or more discontinuous phases embedded in a continuous phase. The discontinuous phase is usually harder and stronger than the continuous phase, and is called the reinforcement or reinforcing materials, whereas the continuous phase in terms, that is the matrix. So properties of composites are strongly influenced by the properties of both materials, their distribution and interaction among them. The composite properties may be the volume fraction sum of the properties of the constituent or may interact in synergetic way so as the provide properties in the composite that are not accounted for the new aircrafts. These are the few examples in our like door to household furnitures to heavy warships. So day by day increase the uses or composite materials in different areas. So now based on the type of matrix materials, we can see in this diagram composite includes matrix and reinforcement. Matrix, and so composite based on matrix, based on structure, based on reinforcement. So based on the type of matrix material, based on the type of reinforcement, based on the geometry. Geometry may be sandwich type, bulk solid mixture, laminates. Matrix based, it may be pure alloys, polymer composite materials, ceramics composite materials. It may be based on the reinforcement. So in further slide, we discuss one by one what are the metal, what are the polymer, what are the ceramics. So just concept is matrix means any type of metal plus adding some reinforcement. Reinforcement means maybe fiber or oxides for increasing the properties of the composites. So now one by one, first one is metal matrix composite. This is based on the pure alloys, metal, based on the metal. So which is known as metal matrix composites. So metal matrix composites have many advantages over monolithic metals like higher specification modulus, high specific strength, better properties at elevated temperature, and lower coefficient of thermal expansion. Because of these attributes, metal matrix composites are under consideration for wide range of application wise. So these are the examples in metal composite materials used in space shuttle, rockets, housing, tubing, cables, heat exchanger, structural members, and many more. So few examples see in our slides: brake rotor, diesel piston, cylinder head, disc brake, caliper. Now second, which is also based on the matrix. So second is the ceramic matrix composite CMC. So one of the main objective in producing ceramic matrix composite is to increase the toughness. Naturally, it is hopped and indeed often found that there is a concomitant improvement in strength and stiffness of ceramic matrix composite. So concomitant means like this. So this is a very useful in by using of the ceramic matrix composite. So for improvement in the strength and stiffness of ceramic matrix composites. So next is polymer matrix composite. The most commonly used matrix material are polymeric nowadays, and uh, I will discuss in further slides. I have a case. I will discuss a case study which is based on the polymer matrix composites. So that is the one case study or research. So PMC is the material consisting of a polymer matrix combined with a fibers reinforcing disperse phase. Polymer matrix composites are very popular due to their low cost and simple fabrication method. The processing of polymer matrix composites need not involve high pressure and does not require high temperature. So these are the properties of PMC, which is very popular in nowadays as a composites. So other reasons of PMCs are mainly two reasons. Firstly, the mechanical properties of polymers are inadequate for many structural purposes, particularly their strength and stiffness are low compared to metals and ceramics. Second reason is the processing of polymer matrix composites need not involve high pressure and does not require high temperature. Also, equipment required for manufacturing polymer matrix composites are very simple. So for this reason, polymer composites were developed rapidly and soon become popular for structural applications. Polymer composites are used because overall properties of the composites are superior to those of the individual polymers. They have a greater elastic modulus than the near polymer, but are not brittle as a metal. So we can this is the one of the example of PMC. So window is based on PMC, timing belt, engine cover, inverter cover. These are the gate, tire, lead. So this is very useful because no not involve high pressure and does not require high temperature. So these are the properties, these are the reasons which is used matrix materials are polymeric. These are the further examples or applications of PMC. A potentially high volume market for PMC lies in construction applications, especially in construction. So for use in buildings, bridges, housing, lampposts. So these are the different lampposts are used in our roadsides and smokestacks, highway culverts. So widely use of PMC in a nowadays. So in further classification of polymer composites, it first one is particle reinforced polymer, second fiber reinforced polymer. The particle further classify large and micro and fiber continuous or discontinuous. So these are the further classification. So now we discuss about the fiber reinforced polymer. So common fiber reinforced composites are composed of fiber and matrix. Fibers are the reinforcement and the main source of the strength, while matrix glues all the fibers together in shape and transfer stresses between the reinforcing fiber. The fibers carry the load along their longitudinal directions. Sometimes filler material might be added to smooth the manufacturing process, imparts special properties, that is the reduce the product cost of the product will be reduced. Now second type of PMC, particle reinforced polymer. The particles used for reinforcing include ceramics, small mineral particle, metal powder such as aluminum and composite materials including polymer and carbon black. The particles are used to increase the modulus and to decrease the ductility of the matrix. They are also used to reduce the cost of the composites. Reinforcing used matrix can be common in inexpensive materials and are easily processed. Some of the useful properties of ceramics and glasses include high melting temperature, low density, high strength, stiffness, wear resistance, and corrosion. So now, what are the properties of composite materials? So these are the major properties of composite materials. So we will discuss one by one. First one is high strength to weight ratio. It means fiber composites are extremely strong for their weight. By refining the laminate, many characteristics can be enhanced. A common laminate for say 3 mm chop strand mat is quite flexible compared to the say the we know that uh, second properties of composite materials, it is very popular. Or composite materials should be lightweight. So composite, this is the second. So all composite materials generally lightweight because standard fiberglass laminates has a specific gravity in the region of 1.5 compared to alloys on of 2.7 or for example steel around 7.2. 7.8. So these are the alloys around 2.5, 2.7, or still of 7.8 around. So this is the main properties of composite materials, also lightweight. Next, fiber resistance. So we can see in this figure where fire resistance is very another properties. So the ability of composite to withstand fire has been steadily improving over the year by years. Now, chemical and weathering resistance means composite products have good weathering or properties and resist the attack of a wide range of chemicals. Different chemicals are used. This depends almost entirely on the resin used in manufacture, but by carefully selection resistance to all but the most extreme conditions can be achieved. Uh, because of this, composite are used in the manufacture of chemical storage tank, pipes, pipes, chimneys, uh, ducts, bolts, sorry, uh, so vehicle bodies. So these are the different applications. Now color, जैसा भी आपको color require हो. Flexibility, it is also other property of composite. So design flexibility is very important for this. And now low thermal conductivity. So fiber glass develop has been involved in the development and production of specialized meat containers which maintain prime cuts of chilled metal at the correct temperature for export markets. And last and last properties of composites, but very important for every industry or even nation economy. So that is the manufacturing economy. So fiberglass is an ideal material for producing items of this type for many reasons, including being very economical because of its versatile properties. Fiberglass can be used in many varied applications. So in our case, we use polymer composites. So this is the very economical because versatile properties. Fiberglass can be used in different applications. So now advantages of composites: lower density, higher directional mechanical properties, higher fatigue and endurance, low cost of products or items, versatility और tailoring by design. तो जैसा भी हम चाहे उस टाइप का हम डिजाइनिंग कर सकते हैं. फ्यू different composites को यूज कर सकते हैं. So easy to machine, it is also another example advantages of composites. Easy to machine as compared to metals or any other items, any other material. So higher toughness than ceramic and glasses, can combine other properties in improving the and checking the damping and corrosion. This is the limitation or disadvantages of composite materials. So properties of many important composites are anisotropic. The properties differ depending on the direction in which they are measured. This may be advantages or disadvantages. So this is the limitation or disadvantages of composite material. That is the many of the polymer based composites are subject to attack by chemical or solvent, just as the polymer themselves are susceptible to attack. Composite materials are generally expensive based on the characteristics about the of the composite, depend on the what type of characteristics required for particular application. So manufacturing methods for shaping composite materials are often slow and costly. So for composite fabrication, so these are the different fabrication methods which is used upon based upon the application, based on the requirements. So we discuss one by one. First one is the spray layup method. The spray layup method means spray up. We can see in this diagram, there is the this, so there is the chopper gun are used, and this is the pot for using the resin catalyst, and this is the fiber. So including this is the this. So in this form, so in spray form, then final, that is why required. So spray up is an open molding. This is the we can see in this. This is the open molding composites fabrication process, fabrication method, where resin and reinforcement are sprayed onto a reusable mold. So the resin and glass may be applied separately or simultaneously chopped in a combined stream from a chopper gun. Workers roll out the spray up to compact the laminate. So these are the application of spray up methods. We made lightly loaded structural panels, bodies, tray-fairing, bathtub, shower trays, small. So these are the different items which is made by spray layup methods, fabrication method. This is the second fabrication method, which is the hand layup method, or it is a very popular or method because it is the simplest and oldest open molding method. It is very simple method. So for fabricating composite materials. So in this, at first dry fibers and fiber in the form of woven or knitted, stitch or bond fabric are manually placed in the mold. जो भी आपके पास mold tool है वहाँ पे आप mold, and brush is used to apply the resin matrix like this. So used for apply resin matrix on the reinforcing material. So this is very important or commonly used for fabrication of composite materials, which is known as hand layup method. So various applications of hand layup fabrication methods like wind turbine blades, production boards, architectural molding, and etc. This is the another fabrication method, vacuum bagging. So vacuum bagging applications are large one-off crushing, bonding in production. So these are the applications of vacuum resins. This is the another example method of composite material fabrication and applications of this chemical storage tank, pipeline, gas cylinder, firefighting, breathing tanks. Frustration examples are applications of beam, guiders used in rough structure, bridges, ladder, etc. This is the another resin transfer molding, which is used for small complex aircraft and automotive components train system. So in this, fabric are laid up as a dry stack of materials. These fabrics are sometimes pre-pressed to the mold shape and held together by binder. So these perform are then more easily laid into the mold tool. A second mold tool is then clamped over the first, and resin is injected into the cavity. Vacuum can also be applied to the mold cavity to assist resin in being drawn into the fabric. So sometimes known as vacuum assisted resin injection method of fabrication. These are the another example type of fabrication method. Resin film infusion applications are aircraft radomes and submarine sonar domes. Now, this is the oven case study. This research paper, this is the oven case study and published in Wiley publisher in journal is Polymer Composite. So theme of concept of this case study is the mechanical and three-body abrasive behavior analysis of glass and basalt fiber reinforced epoxy composites. So published in 2020, volume is 41. This is the ACI journal. Or in this case study present the comparative investigation of physical, mechanical, abrasive wear behavior of chopped glass and basalt fiber reinforced epoxy composites. So the composites were fabricated by the fabrication method used for this study is the hand layup technique. The fiberglass, the fibers are we selected two fiber. One is glass, second is basalt. So glass is a fiber and basalt also fiber. So we choose two fibers and study, and in further slide compare of both. Was varied in range of 10 to 40 weightage percentage of weight in the composite at the interval of 10% to find out the physical means what are the density, void content. Mechanical means tensile strength, flexural strength, and impact. What are the impact strength of both composites, and steady state abrasive wear rate respectively. And further for optimization, we apply the Taguchi design of experiment method was used for designing of experimental runs having input controlling variables like sliding distance, normal load, fiber content, and abrasive size. So this case study clearly demonstrated that with increase the fiber content, the density and void content of both fiber means first is glass and second is basalt. Then both fiber reinforced composites were increased. The basalt fiber reinforced composites saw lesser void than glass fiber reinforced composites. The tensile strength, flexural strength, and impact strength of both composites increased with increase of fiber content, whereas glass fiber reinforced composite show slightly lower than tensile strength, flexural strength, and impact strength than as compared basalt fiber reinforced composites. So, however, as far as basalt fiber reinforced composites show better wear resistance than glass fiber reinforced composites. So this is the our case study. So now we discuss in detailing. So before detailing this case study, now we discuss what is the fibers. So we can see in this slide, fiber include fiber may be natural, may be synthetic. So natural fiber from animals, minerals may be abstractions, animals, silk, wool, hair. So and also natural also cellulose. So these are the further classification of natural fibers, and these are the synthetic. So organic, synthetic, inorganic, organic fiber further classified, armament, polyethylene. So these are the different uh, fibers based on different classification. So now what is the synthetic fiber? So our target is uh, we select two fibers. One is glass and second is basalt. Glass fiber out of from glass fiber type of synthetic fiber, and basalt fiber is the type of natural fiber. So what are the synthetic fiber? Synthetic fiber based composites are emerging as a viable alternative to traditional materials in wide range of application. For example, automotive industry, railways, aerospace, and marine applications. And uh, so synthetic fibers are made from different chemicals having their own properties. Fiber produced from these polymers include nylon, polystyrene, acrylic, polyethylene, etc. So synthetic fibers are more in length and are long lasting. So we can see in this, these are the more in length or long lasting. So it has been found that this synthetic fiber composite possesses high stiffness, high strength, and low density as compared to traditional materials. So out of various synthetic fibers, the three most common synthetic fiber used in composite industries like uh, this fiber and glass fiber, carbon fiber, and carbon fiber displayed in this figure. So these are the three most commonly used fiber of the synthetic or for various applications. Uh, Out of these different synthetic fibers, I select for my our study glass fiber. So glass fiber is a type of synthetic fiber, or glass fiber are most versatile and cheap synthetic fiber compared to silver and carbon, widely used in the polymer composite industries, having high percentage of silica content, around 50%, along with different mineral oxides. Glass fiber are lightweight, less brittle, lesser stiff, extremely strong, and robust material. So glass reinforced polymer composites are used where the higher stiffness or of carbon or armament fiber is not. So these are the other characteristics or other benefits which is used for glass for different technical application like high durability, low cost, low density, high production. So these are the reason we mostly use glass fiber as a out for synthetic fibers. So now what is the natural fiber? The natural fiber are the most promising reinforcements substitute to synthetic fibers for fibers reinforced polymer composites, because owing to non-toxic, non-abrasive, higher specific strength, lower density, minimal environment impact, biodegradability, besides desirable mechanical properties compared to synthetic fiber, for example, glass, carbon, and etc. So these are the main characteristics of the natural fibers. So we use natural fiber also. So natural fibers from a interesting alternative for the most widely applied fiber in the composite technology. The environmentally impact is smaller since the natural fiber can be thermally recycled and fiber come from a renewable resources. In the past decades, growing interest for natural fibers composites has resulted in extensive research. The driving forces are cost reduction, weight reduction, marketing, so other applications of renewable materials. So we can see different applications of uh, natural fibers. So we choose basalt fiber from natural fibers. The basalt is a dark colored, fine grained igneous rock composed mainly of clays and pyroxene minerals. It most commonly forms as an extrusive rock such as lava flow. Basalt fiber can be in the form of roving, chalk, yarn, and mat. So this shape upon depend upon the application or requirement. So prime reason of growing market of mineral fibers in technical applications are as following: low cost, low density, resistance, high production rates, strength, electricity, etc. So for this case study, we search previous research papers, and based on the and these are where search previous papers. So purpose of literature review is providing background information on the issues to be considered in research and to emphasize the relevance of the present case study. This review discussed various issues. So the past studies relevant to below mentioned points are discussed. So for research work for this case study, physical and mechanical properties of fiber reinforced polymer composites, thermal and thermomechanical and tribological properties of fiber reinforced polymer composites. So these are the based for searching our previous papers. So these are the few research papers which is shown the physical and mechanical properties of carbon fibers or other. So Omrani et al. According this study about the mechanical properties of carbon fiber reinforced by based epoxy metals, that Orani et al. Showed that incorporation of carbon fiber increase the mechanical properties like modulus and strength of the composite. Other researchers, Ramine et al. Study about mechanical properties of woven made glass fiber that at the weightage of 5%, 10%, 15, 20, 25, 30%. Reinforced polyester matrix results showed that the tensile strength, young modulus, elastic strength increase with glass fiber content. That showed the impact strength decrease about 25% with the increase of the glass fiber weightage. Highest tensile strength and flexural strength were found at 30% of the glass fiber out of these different percentage 5, 10, 50, 20, 30. So better result on the 30% of the glass fiber. And this is the another research paper which given by Arujo et al. So their reinforcement material is the glass fiber, and percentage are choose there in study 20, 30, 40, 50, 60. Matrix is the polymer resin. Fabrication method of composites, and they adopt Handley fabrication method. So these are the different tests conducted: tensile test, impact test, ergonomics test. So we can see in this table the mechanical properties such as strength, tensile strength, or other impact strength. So we can see in this table, so found to be maximum for 40% weightage of glass fiber reinforced polymer. So higher tensile strength as well as higher impact strength on 40% of glass fiber reinforced polyester composite. So when increase the percentage 50, then we can see in this reduce the tensile strength as well as difference the results. So better results for both impact and tensile strength at the 40%. This, according to Biswas studied the effect of red mud, 0, 10, 20 filler of glass fiber and bamboo fiber reinforced epoxy material. They observed and the result of the Biswas studied we can see in this figure. So they observed the glass fiber reinforcement showed higher value of tensile strength, modulus, flexural strength, and impact strength than bamboo fiber epoxy, because this is the bamboo fiber epoxy composites, and this is the red mud filled glass fiber epoxy. So we can see in both figures tensile is very good, and as well as flexural strength also higher as compared to bamboo fiber reinforcement. And this is the another paper, Gopinath. So we can see Gopinath studied the mechanical properties of jute fiber, e-glass fiber, coconut fiber, reinforced epoxy, and polyester matrix, and results showed that the epoxy matrix with glass fiber reinforced composite showed better tensile strength, young modulus, and other stresses. This is the for e-glass also higher as compared to jute epoxy, coconut epoxy, and e-glass epoxy is better as compared to other flagellation and other properties. We can see in this also impact energy also higher as compared to other epoxy polyesters of jute and coconut. This is the other study. So basalt fiber reinforced composite showed higher mechanical properties than the glass fiber. In in tensile strength also better elongation and hardness and products. So as compared to glass and basalt. So this is the another study. So we can see in this again. So glassy epoxy theoretical density is best. So basalt epoxy is better as compared to glass epoxy reinforced. So tensile strength also high. Now these are the comparison of tensile properties of various natural fibers with synthetic fibers. So scissor, flax, so these are the different. So we can see in this glass is thus. Now we come to our study. We adopt method and materials. So we select two fiber materials, e-glass fiber and basalt fiber. These are the characteristics. And matrix materials, we epoxide resins, or these are the characteristics for our study. So composite samples are prepared with different weight ratio of e-glass fiber. We select 10, 20, 30, 40% of weight in step 2, 10, 10, 10 incremental. So we can see in this in the next table 1. The proposed formulation of the composites were fabricated. So our fabrication method of a composites we adopt used hand layup technique for the fabrication method of composites. So we already discussed what is the hand layup technique fabrication method for composites. So just brief, we can see. So first of all, select this and mix the resin, then proper mixing of resin and fiber, then we use wooden one, and finally this is the final laminate of glass fiber resin for repair. So this is the properties of our composite materials from the supply data. So these are the data properties of e-glass fiber, and this is the melting point for glass, for basalt. So and our composition of composites for glass as well as basalt. So epoxy plus 10%, epoxy plus 20, 30, 40. Sorry. So for glass as well as basalt, so 10 to 14 wattage for then change by again. So this is the supply better. So this is the e-glass epoxy and this is the basalt fiber. And after the fabricated, this we can see final image of fabricated composite. Figure A shows the glass fiber and B shows the basalt fiber. Sorry, A is the basalt and B is the glass fiber. So this is based on 10% weightage, and this is based on 20, 30, 40 as well as 10, 20, 30, 40. So in our case study, different physical and chemical characterization. So these are the techniques which is very standard. How calculate density, find out the void content test. So these are the few methods or techniques. So these are the prepared composites are characterized by the physical as well as the mechanical properties. The theoretical density of the sample is computed using following formula, which is given by Agarwal and Borden. So this is the formula. So here these are the abbreviation. So void fraction is computed by following formula, and tensile testing. So this is very general use. Purpose of the tensile testing is to measure the ultimate tensile strength and modulus of composite with UTM, universal testing machine. So specific to determine the tensile strength of the composite, a flat specimen is used, and the dimension of this specimen is 150, 15 to 10. So according to this standard. So according to standard test method for tensile properties of fiber reinforced polymer composite, that is the ASTM D3039. So these all equipment or setups are available in our institute laboratory, which is known as tribology center, tribology lab. Now flexural strength testing, flexural test specimen dimension, we can see 150, 15, 15, span length 50 mm and crosshair. So these are the for flexural strength, flexural modulus, intermediate shear strength. So these formulas are used for the find out these values. And this is the impact testing. For impact testing, we can see in this diagram also. So the dimension of specimen according to ASTM to standard 64 and 12.73 mm cube. Depth of the notch is around 10 mm. The specimen is clamped in a square support. We can see this. So square support and is struck at their central point by a hemispiral bolt of diameter 5 mm. The respective values of impact energy for different specimens are recorded directly from the dial indicator. So we can see in figure. So the pendulum impact testing machine ascertains the notch impact strength of the material by centering the V notch specimen with a pendulum hammer, measuring the spent energy and relating it to the cross section of the specimen. And this machine is used for the three body abrasive wear test. So were performed as per the ASTM G65. We can see in this machine. So there is the this is the specimen holder, and here sand nozzle abrasive wear is, and this is the wheel, and these are the loading lever, dead weight. So the control factors for three body abrasive wear test are given in table. So sliding velocity. So our control factors are sliding velocity, fiber loading, normal load, sliding distance, and abrasive path. So these are the units for different factors. Centimeter per second for sliding velocity. So these are the units for respectively. So these are the formulas. By help of these formulas, we find out the loss of weight, volume loss, specific wear rate. This is the specific wear rate given by this formula, and these are the SS means sliding distance and normal load. So these are the standard formulas for find out the different values. Now result and discussion of this case study. Basically in this the comparison between the theoretical and experimental densities, void content, ultimate tensile strength, flexural strength, impact strength of both, as well as glass fiber and basalt fiber. So basalt fiber reinforced composite are shown in this table. So in the first step, the physical and mechanical properties of chopped e-glass and basalt fiber composite were analyzed first of all, and second is the steady state wear rate and comparison of both glass and fiber, and finally the most significant parameter for specific wear rate with the help of ANOVA were determined. So these like these physical and mechanical properties and other properties we discuss one by one with results. So we can see these are the fabricated. Now we can see in the chart. This is the graph. So effect of void contained on e-glass and basalt fiber reinforced composite. So we can see in this chart shows the different percentage at the 10%, 20%, 30%, 40%, and these are the experimental density, and blue line shows the theoretical. So we can see in the physical characteristics of glass fiber reinforced epoxy. So we can see in the volume fraction of void increases with the increased intensity of fiber reinforced as shown in the figure. The so what is the possibility? Actually, reason is this. The possible reason for increasing the void may be poor fiber matrix interface bonding of the composites and incomplete wetting out of the fiber by the matrix. And second is from the results, it also shown that the void friction of basalt fiber composites are lower than the glass fiber. So this is the another result. So if we can see in this, the result shows the effect of fiber loading on tensile strength of chopped glass epoxy and basalt epoxy composite. The tensile strength increased with increase in fiber loading of the composite. So from the results, it may be observed that the value of tensile strength of both glass and basalt composite increase with increase the fiber percentage. So for glass and for this is for the basalt and for the glass. So when increase the percentage of fiber, then increase the tensile strength of the epoxy glass fiber as well as epoxy basalt fiber. The reason for increasing the tensile strength may be both glass and basalt fiber primarily carry load and is transferred to epoxy matrix without the failure of matrix material, inducing better stress. It is also observed that basalt fiber composites shows better tensile strength when compared with glass fiber reinforced epoxy composite. So we can see here in this. Now this may be due to because maybe better interfacial bonding between basalt fiber reinforced and epoxy matrix, or maybe basalt fiber reinforced composites have lower voids than glass fiber reinforced composites. Now, next is effect of fiber loading on flexural strength of chopped glass epoxy and basalt epoxy composite. The flexural properties of both glass and basalt fiber composite increase is due to better interfacial adhesion and bonding of fiber from the matrix. As shown in figure, the flexural strength values for chopped basalt fiber composite were found to be higher than the as compared to chopped glass fiber composite. So this may be due to the very minimal void content in basalt fiber composites compared to glass fiber composite. So basalt fiber matrix have better interfacial bonding, so the fibers are enough to arrest cracking. So we can see in this figure, so yeah, compare between glass and basalt. So basalt fiber is uh, higher increase with fiber. So next is effect of fiber loading on impact strength of chopped glass epoxy as well as basalt epoxy composite. So we can see in this figure also the this line shows for basalt fiber and this line shows for glass fiber. So it can be seen that impact strength of basalt fiber composite is higher than glass fiber composites. It may be the outcome of lesser void content in basalt fiber composites compared to that of the glass fiber composites. So lesser void content was attributed to better interfacial bonding between fiber and matrix that uh, uh, efficiently enhance the impact load bearing capacity of the composite. So result is hence chalk support fiber reinforced epoxy composite shows significant improvement in mechanical properties with fiber percentage than glass fiber reinforced epoxy composites. And now this is the steady state abrasive mass loss and specific wear rate. So first is effect of upgrading distance on wear mass loss of glass fiber resin. So it can be seen from figure that all the composite wear mass loss increases with less to upgrading distance. So we can see in this. So these are the abrading distancing at 500, 1000, 1500, 2000, and these are the different percentage of it, and these are the wear loss. So we can see in this the highest wear mass loss was observed for 10. This is the black. So this is the 10 weightage of percentage of glass fiber epoxy composite, and lowest was observed for 40 percentage of weight glass epoxy fiber. So and this is the different review. So wear mass loss, and this based on at 40 Newton, and this the result shows based on distance at 60 Newton load at the 60 Newton load. And next is effect of abrading distance on wear rate of GFRP composite. Wear rate decrease with increasing in abrading distance in this case. So specific wear rate is decrease when increase the abrading distance at 40 Newton as well as at 60 Newton. So the lowest specific wear rate 0.0155 millimeter cube per Newton meter was found for 40 for this 40 Newton 40 weight of percentage glass fiber epoxy composite highest specific rate this, and was found 10% for this on the 40 Newton load. So a similar trend we can see this. This is the similar trend was also observed with the increase in load from 40 to 60 Newton. And effect of abrading distance on wear mass loss of basalt fiber epoxy. So as similar glass fiber, the highest wear mass loss was observed for 10 weightage of percentage basalt fiber epoxy composites, and lowest was observed 40%. So we can see in this figure. So this for the load is 40 Newton, and this is the 60 Newton. So these are the similar trend for 40 to 60 Newton. Now next is the effect of upgrading. It can in this slide it can be seen from figure that for all the composites wear mass loss increase with respect to abrading distance. Now next is effect of abrading distance on wear rate of this. So wear rate decreases with increase in abrading. So this trend in the so lowest specific wear rate was found at for 40% weightage of this, and rate was found for this composite. That is the then compare this, and this is the similar trend was also observed with the increase from 40 Newton to 60 Newton. So for optimization, we using the Taguchi techniques. So Taguchi design of experiment. So in this experimental runs were simulated using L16 array of Taguchi design of experiment. So we select 4 factors: fiber loading, normal load, sliding distance, and abrasive size. So we select the L16 array of Taguchi design for experiment. So the experiment specific wear rate SWR calculated using equation third and corresponding SI ratio and shown in the table. So our 16 experiments, 4 experiments for 10, and again next 4, next 20, and next 4, next 30, and like this 20 for load are 20, 40, 60, 80, 20, 40, 60, 80. So like this sliding distance 500, 1000, 1500, 2000, as well as an abrasive size 100, 200, 300, 400. So these are the different. So we can see in this table. So these are the results for 16, and these are the SN ratio for our simulations. And now we can see in charts and table. So chart shows the graph shows the SN plots. It can be observed that the mean SN ratio for experimental runs were found to be 36.68 dB. So here, so this is the so this is the fiber loading. This is the normal load for 20, 40, 60, 80, and these are the percentage 10, 20, 30, and these are the distance 500, 1000, 1500, 2000, and abrasive size are the 100, 200, 300, and 400. So we can see in this. So 36.68 is the decibel experimental runs. Then so final result is this. So the result was analyzed at the 5% significant level, which is denoted by P. We know that. So the value of P denotes its contribution on the total variation of the output. It means SWR. Lower value of P denotes higher will be its contribution, and we can see in this table easily. These are the factors: factor A, fiber loading; factor B, normal load, and sliding and abrasive. So these are the degree of freedom, and these are the final result. So we can see the order of percentage contribution on wear performance of GF glass fiber. So abrasive size, that is the 34.25. So abrasive size is highest from sliding distance 33, and then normal load, and lowest is the 4.97. So wear performance of glass fiber and composite is abrasive size is greater, then sliding also greater than normal load, and it is greater than fiber load. So these are the results, ANOVA results for chopped glass fiber, and as well as same for basalt fiber. So we can see in this SI ratio for experimental runs were found 38.06. So this is the for all factors, and these are the results we can see in this table. Table shows the for a specific wear rate for chopped basalt fiber. So again this. So 37 for abrasive size, 31 sliding distance, and this. So we can see in this result. So finally, discuss on the surface morphology. So in the three body abrasive wear, rubber wheel with the presence of silica and moves against the surface of workpiece after n tons of rubber wheel wear occurs on the surface of the workpiece. So we can see first figure A shows figure A shows the uh, abrasive wear surface of the glass fiber reinforced epoxy composite with 10 uh, with 10 percentage of weight fiber loading due to three body abrasive wear glass fiber removed on the surface, and as well as this for figure B shows the arrangement of chopped glass fiber in matrix material, and this uh, and this. So the variation of diameters here 13.49 micrometers and here 11. So these are the diameter variation also of glass fiber was shown in figure C, and due to better bonding characteristics of basalt fiber and epoxy enhanced low matrix wear and fiber damage to the reinforced composites. Fiber breakage of glass fiber composites has increased considerably at 20 Newton load. You can see in this figure D. So now conclusion of this case study. So this is the experimental study, and it was conducted chopped glass fiber reinforced polymer composites to investigate the effect of fiber loading from 10 to 10, 20, 30, 40 weightage of percentage on mechanical, physical, and as well as abrasive wear properties of the composite material. So mechanical properties, we studied tensile strength, flexural impact, increase in fiber loading from 10, 20, 30, 40. So overall results are abrasive wear rate under steady state condition for glass epoxy composites shows improvement. The optimization techniques which use Taguchi experimental analysis reveals the ranking order of significance of input control parameters for glass epoxy composites are abrasive size, sliding distance, normal load, and fiber loading. From the analysis of results, it can be concluded that the optimal properties are obtained for 40% of weight chopped glass fiber reinforced epoxy composites and 40% of the basalt fiber reinforced epoxy composite. So these are the results of our case study, but research is not end. So in future, the future study can be extended to new polymer composites having different fiber, may use different filler combination, and resulting experimental findings can be further analyzed. So these are the key references of this case study. Thank you.
Thank you, sir. If you have any question regarding this presentation, you can ask. If you have any doubt, you can unmute yourself and you can ask question. Okay, I think there is no question. So thank you very much, Meena sir, for giving good information from the selection of the fiber, then the manufacturing as well as the testing. Means this is the complete actually process from the starting from the selection from the to the testing. So once again, thank you very much, sir. And I am also very thankful to all the participants, those are connected till now. And next session will start at 3 p.m. today. Okay, so we will meet at 3 p.m. with the same